Okay, here's another example where we're actually going to be finding the arc length of the circle now and not the area. We do it the same way we would do the area of a sector, except when we set up our ratio, we're using the circumference of the entire circle instead of the area of the entire circle. So instead of finding area, we're actually going to go ahead and find circumference first. It says here if AOB is 48 degrees, that's this angle right here, and the radius is 4 inches, that could be OB or it could be OA, is 4 inches. What's the arc length from A to B? And this is typically written, and this is something you're going to have to get familiar with, this is typically written as arc length AB, like this. You'll see that a lot. So we're finding this here. So I'm going to go ahead and find circumference. To find the circumference, you have to do pi times diameter. And we're not given the diameter in this case, but we are given the radius, which means we kind of are given the diameter. All we have to do here is just double the radius, because the radius is halfway across the circle. The diameter is all the way across. So it's like imagining that you have a line that goes all the way across, which means we know that we can double the radius. So the entire diameter would be 8 inches. So I'm going to do pi times 8. And we're going to write this as 8 pi. Now I get to set up my ratio. So I'm going to set my ratio set equal to a ratio, which is my proportion. The entire circle is 360 degrees. And the circumference of the entire circle is 8 pi. So I've got the entire circumference around the entire degrees of the circle, and I'm going to set that equal to the arc length is just part of the circumference. We are only finding the distance from A to B. So it's like taking a piece of the circumference. So I'm going to set that across from each other. That's what we're trying to find. So that's my x, or that's my variable. And then I put the degrees across from each other. I'm not trying to find the circumference of the entire circle, so I'm not going to use 360. I want the distance from just A to B, and the distance from A to B is associated with the central angle of 48 degrees. So I've got to put 48 degrees here. And then I cross multiply. 360 times x is 360x, and I'm setting that equal to 8 times 48, which gives me 384 pi. And then I divide by 360. And I get x equals, let's divide this by 360. I get a decimal. And this is where I get to use my handy dandy math fraction key. So I'm going to hit the math key, which is right here underneath the alpha. I'm going to use the very first option, which is frac, and I'm going to hit enter, and it's going to turn my decimal number into a fraction, so I get a more exact answer instead of approximating this. I'm going to get 16 over 15 pi, and this whole problem has been in inches, so it's inches, and I'm not going to square it because I'm not finding the area. It's just inches. And once again, I should have done this on my my circumference. My entire circumference is 8 pi inches. But the piece of the circumference that's from A to B is 16 over 15 pi inches. So that's just the distance from A to B. And that's how you find arc length of a sector.